It's a graph which I have depicted by using the mathematical expression which I've used. It's a logarithmic increase when we add more antenna elements in an array, and this is the gain which we get by adding more elements. So it's a logarithmic increase in the gain with the MIMO array configuration. These are some of the salients 5G cellular communications and next generation wireless network applications, independent, uncorrelated multiple sub-channels and data transmissions, increases resiliency of a transmitted signal and the channel capacity, multiple parallel data, time division duplex, data transmission increases throughput, multipath independent propagation, high multiplexing gain and power efficiency, high data rate and optimized expanded coverage, common frequency can be steered simultaneously in multiple directions. Very briefly, I explain the Beamspace multiplexing capacity. Receive SNR improve without extra power consumption. Multiplexing gain could be achieved by Beamspace multiplexing. Linear increase in the capacity due to spatial multiplexing gain that is governed by the number of beams R. This is the R in the mathematical expression that increases the capacity by using the Beamspace multiplexing. Very briefly, in Beamspace multiplexing, we actually synergetically integrates the performance parameters of antenna space multiplexing and traditional beamforming. That is the high multiplexing gain and high power efficiency. Both of them are added, and in that case, antenna spacing which we can use in Beamspace multiplexing is lambda by 2, and it is also manageable when we are using higher frequencies because antenna element spacing is less lambda antenna element spacing is possible in 4G and 5G and other next generation networks. So signal spatial property in beamspace multiplexing is that multiple dedicated directional signals and a domain is beam domain. Multi-beam signal processing is used and exploited. This is the simulation and animation which I have created to give a very good intuition about this beamspace multiplexing concept. So if you have, we have two users, user one and user two, and we have a data stream, user equipment one data stream and user equipment two data stream, and all of the data streams are, you know, divided into further sub chunks, and each sub chunk is transmitted to each independent antenna. We have antenna array elements for user equipment 2 and we have antenna array elements for user equipment 1. So each packet is connected and each stream is connected to different antenna array. So what we do spatial multiplexing by changing the phases, and we also do the beamforming by changing the phases at the input of the antenna array. So, if all these steered beams have independent of each other, and user equipment one beam is independent of the beam that is steered at user equipment 2, so there will be less interference. We get higher special multiplexing gain, we get higher data rates, and capacity is also increased. And keeping the same power, we can accommodate multiple users and enhance the capacity. These are some of the references which I have used for the making of this presentation, and that's all from my side.